Hello guys, welcome back to my channel Algorithm Minds, and in this tutorial we are going to solve a set of system of equations in Python, and I'm going to show you step by step how we can actually solve set of linear equation symbolically in Python. So first of all, let's describe a problem statement. For problem statement, we have exactly like three equations, linear equations that have three unknown variables, x, y, and z. So we have, based on those three unknown variable, we will form three equations: equation 1, equation 2, and equation 3. And for equation 1, we have like 3x plus 2y plus z is equal to 10. Equation 2 is x plus 4y plus 2z is equal to 15. And equation 3 is x, y plus z is equal to 8. Just neglect that part. So these are a set of equations. You can form your own equation. This set of equations can be either in like summation or subtraction, but can they also be in like in multiplication or divisions. So the very first step we are going to use is we are going to import our library. In our case, we are going to use the library Sympy that will solve these equations symbolically. So we will use this line import Sympy as SP. And the second step we are going to use, we are actually going to define the variables. So in our case, in our set of equations, we have how many known variables? X, y, and z. So we'll declare a variable x, y, and z with comma and then equal to, and then we will call the function symbols from the library Sympy. And within the braces, we will pass the input argument as a string with the variable names x, y, z, where space will actually help the function identify these are different type of variables that we are going to use in our set of equations. So we have x, y, and z. So once we have actually defined our symbolic variables, so what is the next step? Again, the next step will be to actually define a set of equations. And for this purpose, we are going to use the same library and we'll call the function eq, as you see here, sp.eq. And this function will actually define the set of equations, and like either you have one equation, two equation, three equations, or you have 10 equations. So let's go with each line step by step and define each equation. So we are defining equation 1 that corresponds to this equation, and we will pass call the function sp.eq. Then we have like braces here and curly braces, and then we are passing two input arguments. You can see that these two input arguments are separated by comma. So we have like the first equation is here like 3x plus 2y plus z is equal to 10. So obviously in MATLAB in Python we are going to use asterisk for multiplication. So we have 3 asterisk x, 2 asterisk y, and plus z. So this is our the left hand side of our first equation, and in order to define the right hand side of our equation, we are going to use comma, and then we will pass the value here 10. So this is how we actually define equation 1. In the same way, we are going to define equation 2. So we have we use the same input argument, like we will call sp.eq. Then we will define our second equation left hand side, then its right hand side. And the same way we are going to define equation 3. First we will declare a variable. Yes, you just keep that in mind. Like for every equation you define, you will have to declare a variable. You see that for here, like equation 1 I am using eq1, equation 2 I am using eq2, and equation 3 I am using eq3. So that's how you declare variable, and then you call the function eq, and then you define the equation left hand side and right hand side. That's how you are going to define equations. And if you have some questions, if your set of equations are quite complex, you can just actually comment down in the video, and I will be happy to help you out. So now we have declared our variables here, and we have declared our equations here, and let's move on to actually defining the set of let's move on to actually solving this set of equations for unknown variables, so we can get out the values of x, y, z. What are the values of the x, y, z that will satisfy all these equations in mathematical notation? So that's how what is the problem has been defined. So we will first declare a variable solution, then we call the function solve from sp, which is again Sympy library, and after calling the function, we will pass two input arguments. As you can see that this is the first input argument and this one is the second input argument. So the first input argument actually are the set of equations we have defined earlier, eq1, eq2 and eq3 within the braces. You can see that here we have like set of equation within the braces, and the second argument will be actually the unknown variables x, y, z. We want to actually get the values of it. And once like this is how you actually like solve set of equation using Sympy, using this line of code. Now you have defined your variables, you have defined your equations, and now you have defined your you have called function solve to actually get the values and calculate the values of x, y, z. Now you have the values of x, y, z. Now you can simply use this simple plot code to actually print those values, but you can see that we are calling the index x, y, z here. So this is the simple print notation. Then the second one will be solve, and square base is x, a square base is y, and square base is z. So let me just run this code again for you. So you see that now our set of equations have been solved, and we can see that we have a value of x is equal to 1, y is equal to 0, and z is equal to 7. So this is how we actually solve a set of linear equations in Python using Sympy. And using the same notation, you can actually solve more complex equations. The formula and the notation will be the same. Declare variables, declare set of equation, call them function solve, and then finally print it or use it for your further calculations. So that's it for now. And those of you who don't know me, I'm Asan, and I work on programming languages and also teach programming skills to people around the world. So thank you for this tutorial, and stay with me for more tutorials. And in the upcoming tutorials, I will be posting videos about optimizations and other mathematical modeling. So stay tuned. Thank you for joining.